So let's start with a recap of what we did in the last lecture. So we were discussing about Chomsky normal form. So this is in short known as CNF. And in the meantime, we saw an algorithm that could be used for converting that grammar into Chomsky. You can visit these sections for more details about the content of today's lecture. So starting off with a recap of Chomsky normal form. So Chomsky normal form is somehow a form of a grammar in which you have to obey these three rules. So if you talk about first one, so you could see you can have only two non-terminals are variables on the right side. So you are not allowed either one non-terminal or more than two non-terminals. If you have a scenario like that, we saw we have to convert them into such a situation where you have only two variables on the right side of the implication operator in every rule of the grammar. And secondly, you can have only one terminal on the right side of every rule. So if you have more than one terminal, so definitely you have to eliminate them by applying these different steps of the algorithm. And similarly, you could see over here, you are only allowed a lambda rule for the start variable only. For example, if you have some different variables means A, B, C, D, you are not allowed to take any kind of lambda rule. So this lambda rule is only allowed for the start variable. So these are the three basic rules, guys, you have to obey in order to get a form that is known as Chomsky normal form for the given context-free grammar. So this was the example that I was talking about, and I think I only applied two steps for that conversion. I would recap those steps for you guys, and then I would head towards the third step and fourth step. So after completing that fourth step, you will see you'll be getting some kind of CNF for the given context-free grammar. So you could see over here is that, you have some sort of start variable on the right side of the rules. So you have first rule in which S is appearing on the right side. And in this rule again, S is appearing on the right side. So this means that this is not allowed that your start variable should be on the right side of the rules. So what you do over here is that you introduce one new variable with its corresponding rule. That would eliminate your start variable from the right side of the rules. How would you do that? This is how you can do that. So I introduced one new start variable which is known as S naught, and the corresponding rule is S naught implies S. Now since S naught is the new start variable, so you can't find S naught on the right side of each of the rules. So this is what we were requiring at the end of the day. So this means that by adding such a rule, you have eliminated your start variable from the right side of each of the rules that you have for the grammar. So this is your step one, guys, okay? So let's move this result of step one on the next page, which looks something like this. And now you have to apply second step. So second step says that you have to eliminate all those lambda rules, okay? So lambda rule is only applicable for the case of start variable, but you could see we have a lambda rule for the case of B as well. So since B is not a start variable, this means that you have to eliminate this lambda rule. How would you eliminate that? Now you know that B is either replaced with small b or B is replaced with lambda. So wherever B is coming on the right side of each of the rules, you would add a rule by replacing that B with lambda. Okay, so if you replace this B with lambda, so that rule would be added, that would give you A implies lambda. So this rule would be added as a result of that. If you replace this instantiation of B with lambda, that would make it as A lambda. And we know that by properties of regular expressions, if A is concatenated with lambda, it will result into A. Lambda would be consumed at the end of the day. So your rule, new rule that is introduced as a result of this, I would say, simplification, that would be S implies A. So these are the two new rules that have been introduced. So once you remove this rule, so you can't see B implies lambda rule in these revised set of rules because we have eliminated that rule. And after eliminating that, we have to somehow make our grammar in such a way that it would result into the same strings, into the same language that we have. for that we have to balance our grammar by adding some rules. So these are the two rules, guys, that we have added over here. Now I would be taking this result of step 2a to the next page. That looks something like this over here. Now if you closely look at these rules over here, guys, you can find one more lambda rule, which is A implies lambda. Now A is not a start variable, so that's why you have to remove this lambda rule as well. How would you remove that? Again, you would check if A is appearing on the right side of every rule. So wherever it is appearing, you have to replace that with lambda, and then you would get a resultant kind of rules. So if you replace that lambda wherever this A is coming on the right side, you would be getting some sort of rules like this. Now I gave you example about this kind of replacement in the last class. We have to replace lambda in this rule, A as A. So I told you have to replace this A with lambda first. That would give you a rule that is SA. Next, you would replace this A with lambda. And then in this case, it would give you AS. And finally, you would replace both A's with lambda. And that would give you S as a rule for that replacement. Now in this revised grammar, guys, you could see you can't have any sort of A implies lambda rule. So that A implies lambda rule is missing from here because we have to remove that rule. So after removing that rule, to balance that corresponding context-free grammar, we added these three rules. Now if you take this grammar or if you take this one, so both would result into same kind of strings or the same language that we get at the end of the day. Okay. So until now, I have described you the conversion process. So we are done with step 2. I would bring this this result of step 2 to the next slide. Now you have to check for all unit rules and you have to eliminate those rules. So could you identify any kind of unit rule for me?
So A implies B or
A
S well.
implies B. Yes, yes. A implies B is one of the unit rules. So do we have any other unit rules as well?
Sir, what about rule 1 S not implies to S?
S implies 8.
Yes, rule 1 is also a unit rule because we have only one non-terminal on the right hand side. So we have two unit rules, or do we have more than two?
Sorry, A implies S.
A implies S. Okay. So
S
we have
implies.
S implies.
No, sir. I am wrong. That is non-terminal.
Okay, okay. So we have only three unit rules. Do we have more?
4, sir. S implies S also.
Yes, S implies S is another unit rule that we have. So this means that you guys have identified those rules correctly. So we have A implies B as one of the rules. We have A implies S as well as one of the other unit rules. And then we have S implies S. This is our third unit rule, and fourth one is S not implies S. Now we have to remove them one by one. Okay, so how would I remove that? So if I look at this grammar, guys, so my simplest rule is S implies S. So why not I remove this rule from here? Okay, because I have to replace S with S. So this means that this is a redundant rule that I have in front of me. So I would just remove this rule from my grammar. So this would not change the effect of the strings as well as language. So bringing this result onto the next slide to make it more elaborative, I would move to the next unit rule that we have identified. So this is the rule that I would try to eliminate. So it says you would replace your S naught with S. So S is coming on the right side of this rule. How would you eliminate this one? So you would replace every instance of S with what? These rules. So if I remove this S from here, so I would just replace this S with this kind of rules. So that would remove the unit rule that says S not implies S. So what else unit rules do we have in the grammar? I would bring this this set of rules to the next slide, and then I would ask any question. Yes, please. Any more unit rules do we have in this grammar?
A implies B.
Yes, yes. So we have A implies B. And I would go for removing this A implies B. Now I know that B can go to smaller b. So rather than writing this capital B over here, can I write this small b instead of this B? In this way I would get rid of unit rule as well. Yes, yes, definitely we can replace this capital B with small b because it would be replaced with this rule. Now if I replace this capital B with B, that would eliminate another unit rule. That was A implies B. Okay? And this is the revised grammar that I'm getting. I could bring this grammar to the next page. That would look something like this. Now if you closely look at this grammar, guys, still you have one more unit rule that you have to eliminate. And that is A implies S.
Yes.
That is A implies S. Now, how would you remove this rule over here? This is quite simple. I would need its answer from your side, guys.
So we would replace S by all these ASA, AV, AN.
Yes, yes. So we have to replace this S with these 5 rules. And that would eliminate the final unit rule from our grammar as well. Okay. Now this is the next revised modified grammar that you are getting after applying step 3. I would bring this to the next page. That would look something like this. Now this is the result of step 3D. We have one terminal and another non-terminal. So this is not allowed in the case of Chomsky normal form. So we have to modify this as well. Another important thing is that we have more than 2 non-terminals as well. So that are ASA, ASA, and ASA. So we have to eliminate these more than 2 non-terminals as well, and these combination of terminals and non-terminals as well. So if we can eliminate both of these situations, which are a part of step 4 that I would be doing in the next step, then the final grammar would be in the form of Chomsky normal form. So let's try to remove more than 2 non-terminals on the right hand side. Okay, how would you do that? You have to introduce one more new non-terminal variable. Okay, and that would be something like this. So I introduce one new non-terminal over here that I'm calling as A1, and A1 can be replaced with SA. Now if A1 can go to SA, this ASA would be modified into AA1, AA1, and then AA1. So A1 is a non-terminal, A is a non-terminal. So both of these non-terminals are allowed in CNF. So that's why we are quite okay with this one. Okay. So let's move this result into the next page. Now, is it the Chomsky normal form or not? Do we need to do something else as well?
Yes, sir, we need to do something else.
Okay, so I think we have to somehow remove these rules because we have a terminal and then non-terminal. So how would you do that? You have to introduce one new non-terminal that would take you to A, and that is A2 in this case. A2 can go to A, and this A would be replaced with A2 over here. Now this is the next modified grammar that I'm getting at the end of the day. So we started with this context-free grammar, guys, at start. So you could see it only have like how many rules? First rule, second one, third one, fourth one, fifth one, and sixth one. So it has only 6 rules at start. But now you can have a lot of rules over here. 1, 2, 3, 4, 5, 10, 15, 16, 17, 18. So we have almost 19 rules in Chomsky normal form.